You ever watch a house being built? It's like a symphony of skilled trades, each one critical to the final product. But there's one part of the job that's often overlooked, the foundation. It's easy to forget about what you can't see, but trust me, a solid foundation is everything. Without it, you're building on shaky ground. Everything from skyscrapers to bridges to your grandma's house relies on a strong foundation to distribute the weight and keep it standing tall. In the world of construction, a weak foundation is a recipe for disaster. That's why we are diving deep today into the world of static pile load tests. They give us the confidence to know that the foundations we are building on are up to the task, because when it comes to construction, safety and stability are non-negotiable. So what exactly is a static pile load test? Imagine you're trying to see how much weight a chair can hold before it buckles. You might start by stacking books on it one by one, watching for any signs of stress. That's kind of what we're doing with piles, those long, sturdy columns driven deep into the ground to support heavy structures. The static pile load test is like our stack of books, but instead of books, we're talking about carefully controlled hydraulic pressure. This test is all about pushing a pile to its limit, but in a controlled environment to make sure it can handle the load it's designed for. We apply a steadily increasing load to the top of the pile, like a giant hand pressing down. As we do, we carefully monitor how much the pile moves or deflects under that pressure. This data tells us a lot about the pile's capacity, how it behaves under stress, and whether it's up to snuff for the job. It's all about ensuring that our structures are safe, reliable, and built to withstand the test of time. All right, before we start pushing piles around, we got to set the stage. First up, we need the right equipment. The star of the show is the hydraulic jack. This beast is what provides the muscle, generating the controlled force needed to push down on the pile. Next, we have the load cell. This clever gadget sits between the jack and the pile, measuring the exact amount of force being applied. And finally, no testing setup would be complete without a reaction frame. With the equipment in place, it's time to prepare the pile itself. We're talking about cleaning the top surface, making sure it's free of any debris or loose material that could affect the test results. Section 4, pile preparation, getting ready for the big squeeze. Now let's talk about prepping the pile itself. Different piles, different soil conditions, different projects, you name it. The engineers, they're the brains of the operation. They'll specify exactly how to get that pile ready for its big test. First things first, we got to make sure the top surface, the pile head, is clean. No loose concrete, no dirt, no rust, nothing that could mess with our readings. A smooth, level surface ensures accurate contact with the loading equipment. Next up, we're talking measurements. We're using highly precise instruments to track how much that pile moves under pressure. These might be dial gauges, or more likely these days, electronic sensors. These instruments, they're strategically placed along the pile. This gives us a complete picture of how the pile is behaving under stress from top to bottom. Section 5, the main event, applying load and monitoring deflection. All right, folks, it's showtime. With everything set up and prepped, it's time to apply some pressure. We're talking about a slow and controlled process here, carefully increasing the load on the pile in stages. Remember that hydraulic jack? That's our workhorse. It starts pushing down on the pile head, transmitting the force through the load cell. The load cell records the exact amount of pressure being applied at every step of the way. Meanwhile, those instruments we've carefully installed on the pile, they're hard at work too. They're keeping a close eye on how much the pile is moving under each load increment. This data is gold to the engineers, helping them confirm their designs and ensure the foundation is up to snuff.